Welcome to All Business No Boundaries, a collection of supply chain stories by DHL Supply Chain, the North American leader in contract logistics. I'm your host, Will Haywood. This is a place for in-depth discussions on the supply chain challenges keeping you up at night. We're breaking beyond the boundaries that are limiting your supply chain. Let's dive in. Today's episode is using the power of data analytics to accelerate digitalization across the supply chain. This podcast was originally recorded at CSCMP Edge 2021 conference, and our guests are Brian Gaunt, Senior Director of Accelerated Digitalization for DHL Supply Chain North America, and Stephen Grover, Director of Data and Analytics, also for DHL Supply Chain. So welcome to using the power of data analytics to accelerate digitalization across the supply chain. Sounds simple enough. This is a hot topic, as most of you know, and one that we have two experts with us today to tell us a lot about what we're seeing in the market and what we're doing with our customers at DHL Supply Chain. Without further ado, I'll introduce Brian.
Good afternoon, everyone. My name is Brian Gaunt. I am the Senior Director at DHL, responsible for the coordination of accelerated digitalization, and I'll give you a brief snippet of what that is in my portion of the presentation. So it is looking at new innovations, both hardware and software oriented, and coordinating those with the business. We are continuously innovating our company, continuing to strive to do business a different way, and this is part of our key strategy. And this is important. It's not just one team doing this. This is really our culture, and we've really progressed in this area in the last 4 years. You know, our goal is to be the leader in innovation, sustainability in this space, driving these demands for our customers and making supply chain even more digital/automated as we can. This is core to what we do, and this is important because it really flows through all levels of our organization and all different business functions. So a big part of what we do at DHL is we focus on the things that are important to us. We drive this process by focusing on specific use cases that drive value for our organization and customers. In the process we follow for this, we have a very structured process around this. So we run this through what we call our innovation funnel process, where ideas start at the left-hand side, and ideas can come from lots of different people, industry experts, our business and supply chain experts, vendors, and we drive these things through a very structured process. So we have dedicated teams in place that look at new innovative processes, and we're not just looking at them because we think they're interesting, we're looking at them to solve real problems. And this is, I think, one area that DHL does a strong job at. As you may have noticed of talking to other robotics vendors, many times these roboticists don't really understand our business and don't understand supply chain, and we really co-develop and collaborate to drive these solutions that are driving value for our space. And then ultimately, after we innovate an idea and we put all the structure around it, we get to a stage called productization. So at this point in the product stage, we really understand the technology, we understand the production rates, we understand the value to the organization, and we're really ready to scale this type of solution. And then that takes us to the deployment stage on the right-hand side. So now, we scale these types of solutions to our 400 plus sites in North America, where there's a use case and fit. So that's an important part of the process. We take an idea, we put the right focus around it, and then we scale, and we scale fast where it fits. And there's lots of different tools, but that's our process. We're definitely a multi-vendor type of company. There's lots of different ways to solve similar problems. So we have strong alliances with many different types of partners that bring software solutions, robotic solutions to our business. And then this matching process that occurs in our productization or deployment stage really goes to the opportunities identified. So it's more than just taking a look at these. We're making these real and rapidly deploying these types of solutions throughout our business. As you can see, we've had over 1,000 go lives just in the last couple of years in these focused technologies. So I think that's the important thing. We're not just a research or institution company. We're driving these solutions, driving them to real value, and making them production solutions. And I'll give you a quick glance at How we organize these 12 categories. There's obviously lots of things to focus on, but this is our kind of perspective on things that are driving value. So these 12 kind of categories here are the things that we feel is driving supply chain in North America the most value. Assisted picking, goods to person, wrapping robots, et cetera. I won't read everything here to you. And I think what's important is these are more than just concepts. These are also driving to be live. And as you can see intermingled in there, within our innovation process, it is a mix of hardware type of solution. So there is robotics, physical robotics, and then the software side of things, which is this these algorithmic optimization stage and other things that are important from a software perspective. Focusing a little bit on the software side, I think this is the important side is as you begin to talk to robotics companies, you'll, at least I'm coming across that most companies are now saying, I'm not a hardware company, I'm a software company. Even Ford said, I'm not a car manufacturer, I'm a software company. So that same mindset has fallen over to our supply chain space as well, where the software side is really as important, if not more important than the physical hardware side. And this is just a sampling of some of the types of software type of solutions that we're actively involved in. Machine learning, machine translation, robotic process automation, natural process learning, all these different software components come together. And I think the most important thing on the slide is the people and the associates. So you can go out and buy, any one of these kind of components, but having the right focus from your associate perspective and solving real problems within our supply chain is absolutely key. So these software components obviously get their meat and drive from the ideas from our associates, and then they're driving value back to them to make their process more automated. So everyone's pretty familiar with when you think of the basic functions at a warehouse, receiving, storage, picking, packing, and delivery. What we've done is we've lined up all these technologies at the bottom to align to those different specific use case. This goes back to we're very much a use case focused innovation company. And what's important about this is all this stuff comes together with this bottom layer. We call it algorithmic optimization or resource orchestration. And this is important because we're tying together both the manual processes and the software and hardware processes and creating this feedback loop. All this information goes to our data analytics engine, and this is optimizing the processes.
Good. So I did have a question on this one for you, Brian. When you put this up in front of customers, how do they typically react, and then how does that discussion go?
Yeah, absolutely. So we show this a lot to our customers. I think it goes over quite well. I think it's easy to resonate that you can see that we have a very focused process. We're not just throwing ideas at different processes. It's a very structured approach to drive these key technologies to solving these key warehouse problems that's occurring. The other thing we're doing with these solutions is we're really not just automating a manual process. We're driving automation and creating an entirely new process because of the automation. And I think that mindset's really key.
Okay. And then how do you prioritize? I mean, you couldn't do all of this at once, I wouldn't think. How do you pick your spots to, start and go forward?
Yeah, I think that's the challenge. We do have some focus technologies. There's a lot on our plate, and we have a relatively small team considering, but we do focus on key solutions that are driving value. The biggest ones we focus on is items that are helping with our outbound pick process. We have the most labor, so solutions that help with each picking, case picking, pallet picking are our highest priority. Along with that is our software suite of things that Steve is going to touch on a little bit from a data analytics perspective.
So I'm not going to make you pick your favorite child, but if you could maybe pick two of these that you think have the most promise and sort of why, and if you have an example or two of where we've deployed them and kind of what you've seen from a results standpoint.
Yeah, I think maybe I'll pick three. From a perspective, we've had the greatest traction. Assisted picking, which this is the locust type of solution, has been very successfully deployed within DHL. We have well over 1,000 bots and rising rapidly each month. These really give us a ton of optimization around each picking. The other area that we're growing quite fast in is a space called indoor robotic transport, and this is the AMRs and AGVs around pallet moving. I think the vendors have finally got it right, at least certain vendors have finally gotten this right, that these are solutions that we are actively deploying in our warehouse. And then the third one, I think, would be the software side, going back to the importance of algorithmic optimization. Those would be our three focus areas.
Okay, and then maybe last question, and then we'll get Stephen up. Commercializing these things, or the cost of these kinds of technologies. I know an example for Locust that we covered on the podcast with Brooks Running, but can you talk about how customers are able to bring these things on at a reasonable cost with an ROI that makes sense, how that's evolved maybe over the last 12, 24 months?
Yeah, absolutely. From a commercialization perspective, we've changed our approach. I think traditional kind of older way of thinking would be look at that particular innovation and then try to commercialize it for that specific site. And that burden is on that specific warehouse or that specific customer. We've taken a completely different approach. These automations now, especially mobile robotics, are very scalable. So the funding for these are occurring centrally. And then whether the vendor has a kind of a RaaS model, lease model, we do that internally. So the sites only pay a monthly usage charge. So we're not trying to commercialize the entire thing for that one site.
And RaaS stands for?
Either resources as a service or robotics as a service. So it's a way you can get, we take these kind of fees and normalize them into just a straight monthly fee.
Okay, great. All right, why don't you get off the hot seat, and Stephen?
Fantastic. My name's Steve Grover. I'm Director of Data and Analytics for DHL. Been with the company about a year and a half. I've been in analytics for about 30 years. What I'd like to do today is help you create a mental picture in your head about how you can think about machine learning and its impact to accelerated digitalization. Think about what you need to be able to do that. One thing you need is you need intelligence. We're going to talk a little bit in intelligence, and unless you're going to have people constantly driving all these things that are digital, it'll probably have to be artificial intelligence. So we'll talk about that. We'll talk about automated machine learning, because we need a tool in order to be able to do that learning, and we'll go through that a little bit. And then we'll talk about composable analytics, because if you have intelligence and you have a tool, you need data to feed it. And you better have a mechanism to feed it really flexibly so that you're not constantly reinventing the wheel. And then if you have the technology and you have the data, then you better have a really strong process. So then we'll get into the machine learning lifecycle and MLOps and what that's about. And then we'll talk about the machine learning value equation, because in the end, if the equation doesn't work right, if there's not value, the value's not greater than the cost, then what's the point? And we'll walk through 3 use cases, kind of give you a feel for what that looks like. So where does the intelligence come from? If you're going to digitize your business, you need something to do the thinking for you, and that's where the artificial intelligence come in. Artificial intelligence has actually been around since about 1950. And it usually came in the form of some basic robots that were programmed with if-then-else type logic, very simple stuff to begin with. Then in 1980, we started machine learning, and that's where you created algorithms that took in data, and then based on that data, it would learn and figure out how to handle certain situations without being specifically programmed for it. And then in about 2010, we started with deep learning, and that was the ability to create neural networks, which is kind of like the way your brain functions, in order to create thinking machines. Today's conversation is about machine learning, because that's really the strongest space right now, at least in transportation and warehousing. The tool set we've been using is we're using some auto machine learning tools, and the advantages of those are that think about who the people are who can think of the business use cases. It's usually somebody in the business, usually a data analyst or a business analyst. They say, you know, if we could predict X, then we could generate value Y because we know it's coming. So, you know, a lot of your data scientists, they also need to know programming. You have to be able to do computer programming. You have to know the business. You have to know ML. You have to know how to wrangle data. But if you're a business analyst who knows a little bit about ML and you know how to wrangle data and you know the business, you can use an auto ML tool. So that's real important for us. In fact, we're strongly embracing citizen data scientists. If you've got this AutoML tool, next you need to be able to feed it some data. And depending on how you approach that problem, you can be reinventing the wheel, the data that feeds both the training, testing, and implementation of your machine learning projects. So what we focused on is creating a set of analytic assets. And then what we can do is take those analytic assets. So let's say we have a use case called warehouse safety. We can take those assets and we can organize them in a way and join them in a way that allows us to be able to create data sets for training and testing our models. Then when the employee gets ready to do the next use case, let's say this one's dock lock. For those of you who don't know, dock lock's a situation in a warehouse where there's no place to put a trailer against the warehouse because they're all full. It's a very bad situation to be in, especially if you got product in the yard you need to fulfill orders. We can take those same analytic assets, put them together in a different way and join them and create the training and testing sets in order to create those models. So we're able to use data and iterate very, very quickly. So you've got a tool, you've got data. Next thing you need is you need a process to make it all work, right? So we start with the development, and the most important part of the development phase is the ideation. And there's two key pieces. One is you need a problem, and then based on being able to predict that problem, there's got to be value. So to get past that first stage, you really have to have a good sense of what is the value if we can solve that problem. Then you wrangle the data, you go through your model building process, and to get out of this phase, you've got to evaluate that you're able to predict it well enough and that you're able to prescribe a solution that will deliver that value. If you've done that, then you've developed a good machine learning model. At that point, you're ready to start talking about deploying the model. If you've got a good working model, you have to figure out how you're going to implement the solution because there could be training issues. You got to make sure you coordinate with the customer. The customers have a big say in what you're allowed to do in their warehouses. Once you've implemented and you start to go through UAT, you might need to tune the model. There might be organizational change issues that happen. Maybe you need a new role in the organization to be able to handle some of the issues or opportunities that come out of making that model. And then you're ready to go live and start using it in real life. And then once that's up and running, you better monitor it because there's a bunch of different things that can happen. So usually you have a set of KPIs that you're monitoring, and if they go beyond threshold, it triggers some kind of activity to check and make sure the model's still on track. Another thing you better do from time to time, make sure the users are still engaged with the way that's working and they haven't drifted back into some old pattern. You could be driving efficiencies and the people decide, I'm going to do it the way I used to do it, and all of a sudden you've lost all those efficiencies, right? And the other thing you better look for is model drift. So model drift is when something has changed to cause the model to slowly come off course. And there could be a business rule model drift, there could be data drift, there could be ethical drift. Maybe you start out and doing something's okay, and then maybe later on it's not okay. And then over time you're going to have to make some solution adjustments. So this is kind of our three-stage life cycle process. And currently we've got several dozen machine learning use cases that are in various stages of this. I'm going to cover 3 of these with you today. Now, I made a big deal out of the value equation because if you think about it, if there's not a value, the sooner you can kill a project that doesn't have sufficient volume, the better off you are. So you got to make sure, you got to constantly look at the value and make sure it's greater than the cost. When you're looking at benefits, most people identify the first 2 either if there's a cost savings or there's revenue, but don't discount these last 2. Risk reduction, if you can reduce your risk over time, you will get real value out of that. And the other one's goodwill. If you do something for safety or something that helps out employees, the goodwill you can create from a machine learning solution is really substantial. And then on the cost side, again, the first 2 people kind of think about development costs. Unless you're developing a model that's costing hundreds of thousands of dollars, you can usually not worry about the development cost. You usually focus more on the run cost because once you're generating value, if your run costs lower over time, you're going to make enough money so it doesn't really matter. But the 2 costs to look out for is that prescriptive activities cost. And for those of you who are not familiar with that is that's if when you when you develop your solution, usually, okay, let's say I can predict that there's going to be an accident at a warehouse. Well, I have to do some things. I have to prescribe some activities to keep that from happening. And the other one is opportunity cost. If you're working on this machine learning use case, you're not working on this one. 3 use cases. Predictive cycle counting. In the warehouses, we do 2 kinds of cycle counting. We do cycle counting where we go through all of the locations in the warehouse and identify what's in inventory at each one of those locations. And then there's cycle count or count back, where when you do a pick from a particular location, they do a count back to see what the remaining inventory is. This process identifies where the high error possibilities are and focuses on those locations. And what this allows us to do is they have much more accurate inventory, way less work effort, and huge returns on this one. Second one is predictive warehouse safety. I was talking about that a little bit. All this is looking at all of the factors, training, tenure, the Super Bowl happening. Look at all of those features in order to predict where those are going to happen, and then take actions either through a phone call or through maybe talking to a robot to make sure that some activity does or doesn't happen to avoid an accident. And then the last one, predictive absenteeism. This is really about making sure you can maintain staffing levels. We're not really worried about is Jane Doe or John Doe going to be there that day. They're looking at the whole team and saying, based on either holidays, religious events, whatever, we could see this kind of an impact to our non-exempt staffing, and then make adjustments in our staffing so that we allow for that whatever's going to happen, so we can maintain performance and really reduce overtime and improve our throughput. And it can really improve, this is a goodwill item, right? Employee stress. If you're on a team of 7 and you see only 5 show up that day, you're like, oh, today's going to stink. I know that was fast, sorry.
No, good examples. I had a question around who do you talk to give you the ideas? So who provides the best input for what could be an array of ideas, I would think?
The best ideas don't come from data scientists. That'll be the first clue. The best ideas come from business people in your organization, people who are close to the front lines and see the activity. So the business analysts, the data analysts, that's why we're really big on the citizen data scientists, because we're seeing some of our most interesting use cases like predictive absenteeism, like warehouse safety from those folks.
And then back to that value equation bit, how do you measure that, and when do you know an idea is a bad one? Is there, are there red lights that go off that you say it's time to move on, or how do you sort of calibrate that?
Sure. So there's a couple places where that typically occurs. Again, you want to kill an idea as quickly as possible, not because you want to kill the idea, because you don't want to waste your time, because there's other ideas that could be of higher value. There's a couple key places. One is when you're building the model, if you can't predict well enough, you've either got to get more data, you don't have data that's predictive enough, or maybe it's not the right frequency or the right grain, but you got to make sure you have the right data to get a high predictive rate. Another place is in evaluate and prescribe. When you're thinking about those prescriptive actions, if the actions you have to take are so costly that they don't make sense, that's another place you can kill it. You can kill it in solution planning. When you're looking at the solution, you say, oh, in order to make this work, we really need to hire a bunch of people. Usually by implementation, by 2 and 3 and deploy and 4, once you get past 1, you're usually pretty confident that it's going to happen.
Okay, good. And then maybe to bridge the 2 subjects together, you talked about acquisition of data, and I don't think we're lacking for that, even pre-automation when we're just sort of at the WMS level, or TMS. We're sitting on huge amounts of information that are flowing through on a daily basis. Brian, when you think about more automating technologies, how do you think about the data flow that comes out of those, actually adding on to the pile of data? And then what do you think about from a data science standpoint of sifting through that down into something that's either usable, or you've got technology that can weave that into something of business value?
Yeah, we're definitely not short on data, and probably you aren't either. But our goal isn't to create a data swamp of things. So we definitely, when we look at data elements and data components, we want to make sure that we're pulling relevant data that's going to drive us the highest value. So the important things of feeding data out of these robotic solutions is to make sure we're really focusing on the key data, and it's at the right level. In some cases, we actively summarize that up to a higher level. In other cases, we work at the lower level. But I think it's important to really spend some time and not say, just give me everything you have and I'll work through it, is to really focus that data set down. So then we pass it over to Stephen's team, they can be a bit more focused.
So yeah, I talked about that a little bit before. A lot of folks try to, for example, you could take a data lake and put all your operational data in a data lake. And if you've got 500 sites across North America, you have separate instances, the warehouse management systems, the labor systems, you got multiple HR systems, you got multiple timekeeping systems, and you tell your data scientists, oh yeah, put together this use case, and they got to look across thousands of tables. What are the chances you're ever going to be successful? Pretty close to this, yeah, pretty close to this. But if you can create objects that a user intuitively understands what it is and make it something that they can use over and over again, you can do things very quickly once you have this up. Once people grasp how they can glue this together, because there's a big difference between I have to be a programmer and I have to do a join between two tables in SQL. Most people can do a join, it's in the answer is in the question. How do you join two tables? You use the term join, right? So that's pretty simple. Whereas programming and having to glue together hundreds, in some cases thousands of tables, that's a much bigger task.
So you talked about the concept of citizen data analyst, because these are fairly highfalutin concepts, especially when you think about traditional warehousing and transportation. And I know they have impact, but I think where do we find the people to do these kinds of tasks? Because they don't meet the historical profile of some of our folks. Where are we finding folks? I mean, I know you're relatively new. You've been around for a while, Brian. And when, for younger people, what are fields of study or experiences that they ought to consider getting so that they can kind of tap into this?
So the term I use is citizen data scientist, because like I said, I've been in analytics for 30 years. I've known lots of data scientists. A lot of them have PhDs, advanced degrees in statistics, and a lot of them have programming backgrounds, and most of them will be anywhere from $150,000 to $250,000 a year in salary. So there's usually very few of them you can afford to have on your team. And then you have the whole industry and business knowledge thing, right? So how do we grow ours? We have an analytics community of about 200 people in NORAM. And those people all kind of know SQL. They all know the business because their number one job isn't being a full-time data analyst. They've got to actually make sure the business is running. So what we do is we take and give them the AML tools. We give them this data. And so we're growing our citizen data scientists. That's what we're doing. We're not going out and hiring them. We're growing them because, quite frankly, they're very hard to find in the market. When you do find them, they cost a fortune, and they usually don't have your industry expertise. So that's how we're fighting the challenge.
That's exactly it. I mean, we do hire PhDs, and we do have those individuals on the team, but I think mixing the ML, machine learning knowledge with the business is absolutely critical. So, we've found better success tapping into this broader 200 kind of pool of individuals and then bridging that gap and teaching them some of the more advanced analytics skills in order to operate the tools. We do have both, but I think the latter, as Stephen said, has been more successful.
Yeah, and I have heard from our college recruiting channels that the kids coming out of school now are more predisposed to this kind of, these types of skills, and they like it. So Brian, what percent of our customers do you think are today saying, I want a robot because it's cool?
100%, I think.
And what percent of that 100% can see the business value coming from it?
I think our customers are the same like anybody else on different spectrums from really understanding the technology. Some are driving it and really want to see it in their operation because the cool factor, we're able to drive and show the real business benefits of putting in those solutions as well and help bridge those gaps in conversation and drive to see why these types of solutions are really helping their business from a quality, productivity, et cetera.
Okay, great. So thank you, gentlemen, for your presentations today. Really appreciate it.
If you enjoyed the conversation today, please share it with a friend and rate us on Apple Podcasts. You can find us online at dhl.com/allbusinessnoboundaries and follow us on LinkedIn and Twitter at DHL Supply Chain. We'll see you next time.